we can really just basically skip the first section, this section 1, because this is all the stuff that we talked about. We know why notebooks are great. They enable interactive analysis. They make it very easy to share and collaborate. So they make it easy to share both for collaborative purposes and for citation purposes. We talked about how exactly they fit inside of the Terra environment, inside of the concept of the workspace. We talked a little bit about the vocabulary, so there are cells. Incidentally, let's start talking about what the actual things look like. So every one of these boxes here is an individual cell. You can tell what type of cell it is by looking right here. So this is the cell type. So each one of these is a markdown cell. You can change it from a markdown cell to a code cell or one of these raw notebook convert cells. But if you want to be working in Markdown, then obviously it should be in Markdown. If you want to edit any cell, you just double-click on it. So this is what the plain unparsed Markdown code looks like. So if you write your Markdown code into a cell and then make sure that it is in fact a Markdown cell and click Run, then it will render the Markdown formatting. So it looks really beautiful. You can automatically nest these headers. Whoops, pardon me. You can automatically nest headers like this by the number of hash marks. Right, so automatic nesting, and it automatically updates. So these are also double hash mark level, and it automatically updated that section to be 1.2 because now we have a 1.1.
How do you end an edit session?
I'm sorry?
How do you end an edit session?
How do you stop editing? Once you run the cell, then it renders. So you can either click Run or hit Shift Enter, and then that runs the cell. And then you can always double-click on it again to edit it. And the same is true of code cells. So now we'll take the tour around the interface. So it's going to be a lot of what I showed you in the slides, but we'll actually look at where the buttons are and see how they work. So first of all, here is the help menu, where you can find all sorts of useful references for different Python libraries, for Markdown. That's very useful. Next to the help, the most important menu is probably the cell menu. So the cell menu allows you to run cells effectively the same way as the hotkeys or pressing this button, except it also gives you a few more options. So for example, one option that I very often use is the run all below. So a lot of times in a Jupyter notebook, which is really kind of a logical linear progression of steps, you will get all the way to the end and be like, something is still not quite right. And I think that it has to do with something that I did in a cell in the middle of the notebook. So you'll go to that cell, change that, and then make sure to run that and everything below. So it's a very fast way of doing it. In this menu is also where you clear outputs. So you can either look at the current output, so whatever is the cell that you are that you have selected. So here I will go ahead and run this regular Python print command. So we printed hello world. I will select that cell, and I will go to the current outputs and hit clear, and it clears the output. You can also clear all of the outputs in the entire notebook like that. Oops. There you go. The next most important menu is the kernel menu. So we support a number of kernels. We support these 5 kernels if you are working either with the latest version of Python or with Python version 2, then you'll always be able to run that code within Terra notebooks by just going over here and changing the kernel. You can tell what kernel you are currently using up here. So this says we have our Python 3 kernel selected. When this little circle over here is empty, that means that the kernel is sitting idle, so it's not doing anything. Anytime you run some sort of calculation, you'll notice that this icon goes, oh, there, when you hover over it, it says kernel idle. Whereas when the circle is filled, it says kernel busy. So it should flash very quickly. There. So that was very quick, obviously, because it's a very simple, fast command. But when you're uploading modules and libraries, it can be useful to see whether or not you're kind of stuck somewhere and your kernel is idle, but for some reason a cell is not finishing compiling, in which case you will need to go to the kernel menu and hit restart. You can also hit restart and clear output, or restart and run all. So if you're just very quickly trying to go through the same notebook over and over again as you fix it, just run all every time. You can also do that with this button right here. So that's the restart the kernel. This is the restart the kernel and rerun the whole notebook button. So that takes us through cells, kernels. We have several options for inserting cells. We can either use the insert menu, or we can use this button over here. So we would insert a cell below whichever cell we have selected. So right now we have this markdown cell selected, and if I add another cell there, then I can write some code. For example, I could write some markdown code like hello, and then I press enter. And it doesn't work. Why? Because I have not changed it to a markdown cell. So right now, it just interprets the contents of this cell as if it were a Python cell, and so obviously it thinks that this is just a comment. Whereas if I change this to a markdown cell, it'll change how the edit mode looks, but then when we run it, it will actually give us the markdown result. And then we can go ahead and delete that cell as well. Very simply like that. And then in the edit section, there are also a lot of useful just moving cells around options. So I'm going to delete this cell, and then I'll show you the merging and splitting cells capability, because I think that's pretty neat. So for example, I could merge these two cells by merge. That work? Oh, it merged these two cells, right? So this was a separate cell from this one, and then it merged those into two. And if I want to split them, I would choose where I want them to split by putting my cursor in that location. So I can put my cursor right there. I go to edit, go to split cell. Now those are two separate cells. And then there's lots of different options for moving them around, move this cell up, copy, paste, that kind of thing. So that's how we add and remove cells. We've already learned how to execute code cells. Incidentally, one demonstration that I like to do is to show that the computation happens on the kernel even if you don't see it. So we'll do print x. So there, x equals 8, but if over here I do x equals x plus 1, and I run it a few times, it's 1, 2, 3. So 8 plus 3 should be 11. So that's a nice little demonstration of how how the back end works here. So we've already learned how, I'm sorry, yes?
Well, it's kind of scary that you can, by hand, change the result.
Mm-hmm.
Then you don't have a thing that produces a result, the same result every time you run it.
How do you mean?
Well, I mean, I was just thinking that it would be nice if you have a Jupyter notebook and it produces the output out. It does, and it tells you how to produce the output. But if you can like go through and run different things multiple times and get a different output, then you never know if you have an output. Did this code produce it, or did you have to go?
Or did you go back and forth a lot? So that's one of the reasons why restarting your kernel is so often useful. Actually, that's the kind of second part of this. Where did it go? Where did my little number crunch go? So if I then restart, that's just the regular restart. Now if I do this, it's going to say I've never heard of X because I've never run this code before. So if I run that and rerun that, now it thinks X is 8 again, and then I have to do this again. So yeah, the workaround for that is to, if you're not sure, just restart your kernel and see if it still works the way you want it to.
Another thing to note is that notebooks are designed to be used for interactive analysis, so a lot of this back and forth. If you're looking for something reproducible and will stay the same consistently, that'll be workflows, which we'll talk about in the afternoon.
So that takes us through down to where were we? We were at keyboard shortcuts, which we've also already seen. So I use this keyboard shortcut a lot. And I mean, you can start using these if you want, but I think that the menu options are a lot less cumbersome, to be honest.
Pager, and I don't know how I opened it. It was like information about the commands. How do you open? I closed it. How do you open it?
So we've already talked about how to change the kernels. So you'll note that this is always getting interpreted in whatever kernel is chosen here, unless you've chosen it to be a markdown cell. So again, we have both Python 2 and 3, as well as PySpark 2 and 3, and R. And then can I ask, how are we doing on time right now? Because a lot of the exercises in this notebook you can now basically do yourselves. Everything is explained thoroughly in the notebook, which is another nice part of the notebook. Says the markdown cells can give you both instructions and screenshots. They do exactly this, and then right below is a live code cell, and you do exactly that. So here it says copy and paste this, and see if it works. Copy, paste, and there it goes. And so the last thing I will explain about how the Jupyter notebooks work is this little asterisk over here. So you'll notice that next to every code cell, there is this indicator of whether or not the cell has been run, in what order it has been run since the last time the kernel was restarted, and whether or not it's running currently. So right now, we're loading this package, we're installing this package, and that's taking a while. So you can see here our kernel is busy, and inside of the square brackets, instead of empty space, we now have an asterisk, and the asterisk tells us the same thing that the filled-in circle tells us, which is that it's busy. As soon as it's finished doing that, this will turn into a number, which will correspond, again, to however many cells I have run since the last time I've restarted the kernel. So this was the 4th time that I did that. Yeah, and then the rest of this notebook is really just a do-it-yourself kind of thing, where you go through and import the packages just as it describes to do, and it gives you some nice examples of how to generate some visualizations using, oh, actually, I'm sorry, this wouldn't work right now because I did not click to actually upload the, yeah, so it's a little confused. It says, I've never heard of all this stuff that you're asking me to do, because we didn't actually finish uploading all of the necessary libraries beforehand. But just go ahead and click right through those. As soon as they finish, then you can run those cells. So that's our kind of introductory Jupyter 101 lesson. So I'll be happy to take any questions. Is everything working for everyone? Is anybody experiencing just like something is not straight up not doing anything? Great.
Maybe just like a general question about Jupyter. Do you see any like major downsides to using Jupyter versus, I don't know, like if you're working with Python, just going ahead and writing the script?
Downsides with using Jupyter as opposed to an IDE for like Anaconda, something like that. Downsides, the 15 minutes that you might have to wait the first time you launch a cluster. That's about it. Like you have to pay for computational time, but I mean that's the whole give and take, right? You're either going to have to pay for whatever software you need, or you're going to use cloud computing services.
So the package per year, is it going in my content environment or
It's being installed on the virtual machine that you've created in the cloud.
Could you repeat the question?
Yes, I'm sorry. Do you want a microphone?
You have a microphone.
Just give it. Oh, are you saying I should repeat the question? Thank you. Sorry. So the question was, where are these packages actually getting loaded to? They're getting loaded into the virtual machine that you've created in the cloud. So it's literally every time you spin up a cluster, it's like you are requisitioning a computer to be built, to be custom built for you from scratch. So you send some information about the configuration that you want to the cloud, and it configures a bunch of CPUs together and says, this is now your computer. Now do anything you want inside of this computer.
every time I have to install?
Every time you close the cluster, you will have to reinstall?
Yeah,
or every time you
so
delete the cluster?
Every time you delete the cluster, if you hit pause, it won't delete anything. It'll just go into a lower cost state, and then you can just hit play again, and it should take about 2 to 3 minutes to restart. But if you delete, then you have to rebuild a brand new entire virtual machine, and that's what takes that 10 to 15 minutes. So it just goes into like a, I guess you could think of it like a sleep mode while it's on pause.
Great questions. Any more?
Is there a kind of navigating tool you can see the variables or library I defined?
That's a great question.
So what's present in your thing? The next notebook I run has a command that tells you the history of everything you've loaded in there. So I can show you that command. As for what files exist, if you click on the Jupyter logo, it actually takes you to your files on your virtual machine, which I don't think there are any right for this one. Oh, there are, because it's your cluster and you've been working in this cluster for a long time.
This is.
Okay. So these are all files from previous workshops we've run, different workshops, so they're stored in there. But yours might be blank out there.
So just going back to the deleting versus pausing a cluster. So the notebook stays somewhere where you can always access it. And then if you wanted to start the cluster again, you don't have to do anything except just hit that play button to start the cluster again, right? And it takes some time to load up. So deleting the cluster is, you're just taking a virtual machine, but the notebook stays there. So you don't really have to do anything new if you would want to run that same script again.
Yes, so the notebook file itself, so this visualization you see here, exists whether or not you have a cluster. Or sorry, I shouldn't say cluster, runtime environment. When you delete it, it deletes all your files, it deletes all your variables that you may have saved in there. So that, for example, that x equals 8, the line would still exist in the notebook, but the machine would have no memory of a variable called x. When you pause it, you keep those files and the variables. When you delete it, it's essentially like throwing out the computer, and you'll have to build a new computer, and it has no memory of what the old computer did.
But it sounds like because you're essentially, you would want to delete it, otherwise you're going to be paying. Like, so you use it for like one type of analysis,
Sure.
and then you don't expect to do that analysis for another month. You would likely want to delete it and then restart it at some point in a month. Right?
Yeah, you can absolutely do that. I will say the cost of keeping it in sleep mode, it's like $0.01 an hour. So it's very, very low. So if you think you might use it and you want to keep those files, you can, or you can delete it. It's depending on what you want to do with it.
You can move all of your outputs to your Google bucket.
Yes, like Tiffany's saying, you can move all file outputs from your notebook to a Google bucket so you can save them permanently, and that way they won't be deleted.
If I recall, the cost estimate for just having your idle, paused notebook was something like $20 for a month, I think it came out to. It's worth noting that if you have multiple different clusters all open and they're all on the paused, you're paying for that, right? So every month, that's $20 for it just to sit there. So maybe, so a lot of times it's better to just close it up. Oh, and I guess the one last thing that I kind of forgot to actually show you is how to open the terminal. It's very quick. So if anybody here likes working in the terminal, you can click on that button right there, and it opens up a regular command line terminal that's talking to your virtual machine. So again, you're working entirely on your magical virtual computer that you created.
So I'm not familiar with Python, but it looked like you were importing things that were already installed. In R, you install something and then you import it, or library. Can you install various packages you've written yourself on your?
Yeah.
Yep.
Everything works the exact same way it would work in whatever R IDE you like to use. You just have to change the kernel to R.
Yeah. The next notebook we'll be running will be in R, so you can see how we install some stuff.
What are the user privileges on the terminal? Do you have sudo privileges?
I don't know. Do you know? What are the user privileges on the terminal? Do you have sudo permissions?
I think currently no, but we do have, there were user requests about giving users sudo, but I don't think we did it yet. And
So if that's something that matters to you, definitely go to our request page and upvote it. That helps our product owners know what to delegate next. Sure, go ahead.
so like in this terminal, you'll see that string like stat and dash something. That's a cluster name, which will be super helpful when for us to troubleshoot. So if you run into issues, that's something if you give us that string, it'll help us a lot.
Great. So, thank you very much.